Rules in naming alkynes. 1. The main chain must have at least one triple bond. 2. We must number the carbon chain so that the triple bond gets the lowest possible number. 3. We prioritize the triple bond over the substituents, e.g. branches or alkyl groups. 4. We include the position of the triple bond in the name. Right now, let's dive into the lesson.
Alright, welcome to Game Light. Today we are going to be naming these organic compounds, which are what? Alkynes. So if you take a look at all these compounds, we notice something, that all of them are what? They are all alkynes. So now, our first example here, let's start from here. If you notice something, in representing alkenes and alkanes in strokes, every sharp bend are what? Carbons. So don't get confused when you see a representation of a compound like this. So now let's start. Now the first one, we have to what? Make sure we get our least possible number given to what? The triple bond, because that's the first thing to recognize in an alkyne. So obviously this is the simplest here, aside from these two. So now this is the simplest, so that let's start from this one. Let's count. We count here to be what? 1. So let's number. We number here to be what? 1, 2, 3, 4, 5. This is 6 and this is 7. Alright. Knowing that this is 7, is 7 carbon all together. Now what do? What are these guys? Obviously they are alkyl groups. And which alkyl groups are they? They are what? Methyl. And we don't only have one, we have 2 of them. So what do we name it? We have to name it dimethyl. So now we look at the position of this methyl group and we find out that it's what? 6. Is in the 6th carbon. So we just have to name it simply what? 6, 6. Then when we want to put alphabet, we have to put our dash. 6 is dimethyl what? Because it's 7 carbon altogether, we have to name it hept. Now we consider the position of the triple bond. And obviously, from the look of things, we can see that the triple bond is in the 2nd carbon, right? So we have to put hept what? 2 iron. Alright guys, so we've just named this first compound. Now let's simply go over to the second one. Okay, now from the look of things, we have to count and know where to start from, because there is a triple bond here and we must always favor the triple bond. Now on that note, we will have to do what? Let's count. But if we count, we notice that we're actually going to get the same thing from either from this side or from this side. Not like this one that is obvious that we have to start from here. So now let's count. Let's just count from anywhere. I think we should start from here. So we'll say 1, this is the first carbon, 2nd carbon, the 3rd carbon, 4th carbon, 5th carbon, and finally the 6th carbon. Alright, this is the 6th carbon. So on that note, we know it is hex. Alright, so the position of the triple bond here is now 3, obviously. Now, the other things we have to note is these guys. Who are these guys? That automatically become what? Substituents. And now we have to note the position of this substituent. And we have the first substituent to be in the position of 2 and the second one to be in position of 5. So now let's go. And obviously we know one stroke represents what? Alkyl, an alkyl group, which is what? Methyl. So now we have to name it what? This compound will now be called 2, 5 dash dimethyl what? Dimethyl. Now what do? We have to look at the total of the carbons. There are obviously 6. Dimethyl hex. The position of the triple bond is now what? 3. And it's what? 3 iron. Don't forget. We've successfully named this the Iupac way, but that's not all. We also have the common name. But now how do we name it? It has this pattern. When we are naming an alkyne, we recognize the first member of the alkyne family to be what? Ethyne. But this ethyne is also called what? It's also called acetylene. The common name of ethyne is what? Acetylene, right? So now, how do we get acetylene from here? Obviously there's a carbon here, there's a carbon here. So if we circle this place out, what do we get? Acetylene. And after we've gotten acetylene, the other side and the other side is what? Obviously they are what? An isopropyl group. Also an isopropyl group. That makes it for 2 isopropyl group. So we can easily call this what? Diisopropyl acetylene. Okay, so now let me write it down. Diisopropyl acetylene. Alright, this is the what? This is the common name. Alright, since we've named this guy, let's move over to this other compound here. And obviously, from the look of things, it looks like this guy, but that's not all. We also have some substituent attached to it. So now, what do we do? Do we count from any side? No. Obviously, we have to favor the what? The inorganic compound here over the alkyl group. So now let's count. We have to count from this side, obviously. So now let's count. 1, 2, 3, 4, 5, and 6. Okay, we've got our hex. Now, what do? We know the position of our triple bond. Now we know the position of our substance and our substance. So now let's write. So we can name this the Iupac way by calling it what? 2-chloro what? 5-methyl 2-chloro 5-methyl what? 5-methyl hex. Here's what? Position of the triple bond is what? Hex 3 ion. Alright, that is for that. Okay, so now what do? We have to now look at these other guys here. Well, now this one is a little bit different from what we've been doing because we have what? Triple bond, and we also have double bond. Now, who do we give more respect between the triple bond and the double bond? Now, there's an order to these things. In naming a compound where triple bond and double bond is, we give more respect to what? The double bond before the triple bond, even when naming them. So now that means we have to count from here. We have to count from this side, obviously. So we have to count what? We count this as what? Our 1. We count this 2, 3, 4, 5, and 6. Alright, we've gotten the number of carbons here. So now the next thing to do is to put them down. Now, let's go. We'll now call it what? 1 hex. Now, see what we do. Because it's double bond, we don't keep it at hex. We say hexene. We put our dash. The position of the what? Triple bond will now be what? Hex 5 what? Ion. Alright guys. Now, this is how we are supposed to name it. 1 hexene 5 ion. Alright. Now, on that note, what do? We have to move over to what? The next guys here. Now, these guys are a little bit way different from everything we've been doing, but actually it is. There is a presence of a benzene ring in this guy and also in this guy. So now, what do? In an organic compound whereby a benzene ring is not part of the compound, is acting as a substituent, we call him what? Phenyl. Okay, so on that note, what do we now call this guy? As I said earlier, when we were naming this guy, we're naming him with his common name. I said we give respect to what? The first member of the alkyne family, called what? Ethyne. But the common name is called acetylene. So now, getting our acetylene from here, 1 carbon, 2 carbon, giving us our acetylene. Okay, on that note, we'll easily call this guy phenyl what? Acetylene. As easy as that. Now, looking at this guy, same thing. We'll just have to get our acetylene. And after that, the next thing we have to do is what? We obviously can see that there are 2 phenyl groups present. So it's very simple. We are just going to what? Write diphenyl acetylene. Okay guys, now let's move over to these other 2 compounds here. Alright, finally we are here. Now looking at this, it's a little bit complicated because of the presence of the hydroxy group and the what? Triple bond. But we can still do it. So now, but there's an order to this. First of all, we recognize what? We recognize the hydroxy group before we recognize what? Alkynes. But thankfully, alkynes are not double bond are not here. After the double bond, we recognize what? The triple bond before we recognize the halogens and then the alkyl groups. So now, let's go. On that note, let's bring out our carbons. Now, since we have to recognize this guy first before the triple bond, we have to count our carbons from this side. So now we have our first carbon to be here. 1, 2, 3, 4, 5, 6, and 7. Alright. Now, on this note, we've obviously seen where our substituents are. We have our fluorine, we have what? Methyl, we have what? Ethyl. Alright, so now let's name. Okay, so now what do? We bring out everything here. We have what? 5 fluoro. What next? 5 fluoro. 3 ethyl. What do we have again? 4 methyl, right? 4 methyl. Now, this is where it gets a little bit complicated, but we also have to do it. Now, let's go. What do? The position of the triple bond is very important now. So we have to write 3. Now, the number of carbons, hept, right? Hept. Now, this is where we put our triple bond. Heptine. Heptine. 1 off. You get it? So it's that easy. You just have to take it step by step. So we can easily call it 5 fluoro, 3 ethyl, 4 methyl, 3 heptine, 1 off. Alright? So now let's look at this guy. This is, after this we still have 2 more compounds to look at. So now let's be fast with that. So now this one is easy, but now we cannot overlook this. We have 2 what? 2 triple bond in this compound. So now, but where do we come from? We obviously have to come from here. And looking at this, we can see it's a terminal what? It's a terminal alkyne. Okay, but let's just count. We have to count 1, 2, 3, 4, 5, 6, and finally 7. Now, obviously, we now have our substituents, and we now have the positions of the 2 what? Triple bond present. So now let's name this guy. Let's bring out our substituent first. We have what? 5 ethyl. 5 ethyl what? Now, the number of what? The number of carbons. 5 ethyl hept. Hept what? Hept. Now, we have to bring out the positions of this triple bond. Hept 1, comma. Now, the next one is in carbon 3, right? Carbon 1 and carbon 3. So, hept 1, 3, diene. Okay guys, this is how we have to name this compound. So I will just wipe out this whole stuff and let's look at the 2 final compounds we have to treat today. From the look of things, it's kind of tempting to call this the longest carbon chain, but we remember that we have to prioritize what? These guys, right? So now let's count. Our first carbon is here. 1, 2, 3, 4, 5, 6, 7, and 8 is an oct. So now what do? We've gotten our substituent obviously, so we can see the position of our substituent and the position of our triple bond. Okay, so now let's bring out our substituents first. That's the first thing we have to do. So we have to call it what? 3. Which group is that? It's obviously not methyl, it's an ethyl. So 3 what? 3 ethyl. 3 ethyl what? Oct. Oct what? 1 ine. Alright guys, now we've successfully named this compound 3 ethyl oct 1 ine. So on this note, we are not going to name it like this. We are obviously not going to do that because there's an OH here, an hydroxy group, and a triple bond, and obviously we always favor this guy before this guy. So we can't count from here. We have to count from here. Okay? So now let's just do that. 1, 2, 3, 4, 5, 6, and 7. So it's an hept. So on that note, we've gotten our substituent. Our substituent is what? Methyl. So what do? We bring out our methyl first. 5 what? 5 methyl. Now, what do we have here? Now we have to consider what the position of the what triple bond. So how do we do that? No, it can't be 7. It has to be what? 6. Yes. And we were captain from there, that's why we consider this guy as the first guy. So it has to be 6. Don't think like that. Okay? C is what? Head. Now, we've gotten the position, we've gotten the name. We have to put our triple bond. Heptine. We can't complete the spelling yet, so we just put our dash. Heptine what? 1. Oh, it can be a little bit funny because of it was like the other guy when we had an OH, a fluorine, and a triple bond. It's almost the same thing, okay? So we just have to call this compound 5-methyl 6-heptane 1-O. Alright, thank you guys for watching. Please make sure you like, subscribe, and share to your friends who are also going to be in need of classes like this. Okay?
So you pay yourself with you.
I don't do again.
Danger.
So I got some feelings in your